Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
I have started recording. So in today's class, we'll start with verifying how to save the objects within our collection, and we'll verify with respect to HashSet and TreeSet because some extra work is required to save non-primitive types with respect to TreeSet. So in whatever way that we are following for HashSet, it would be the same way for array list or linked list as well. Whether just did anyone verify creating linked list objects or linked list collection? Please try to practice with respect to linked list and verify some of the methods that are available within linked list which are not available in our array list. So to save object, so yesterday's class we have verified how to save integers. We have added 5 integers to the collection and we are able to retrieve the data by using for each loop. So instead of integers, now I want to save employee objects. My employee object consists of 4 instance variables: first name, last name, employee ID, salary. And for each one of them, I have provided setters and getters. You can see those setters and getters. And forget about this method. I have overridden the toString method as well, the toString method which is available from our default object class. I have overridden that and I have provided a meaningful definition for toString method. So whenever I'm trying to print the employee object, it will directly call the toString method. It will provide some meaningful information instead of providing the class name at hash code generation. And in the same way, I have provided a overloaded constructor and I don't have any default constructors. So I'm supposed to create any of the employee objects by using the overloaded constructor only. So we have mentioned that I want to take a collection which accepts employee objects. So hash emp objects equal to new HashSet of employee. So now create 3 or 4 employees. Employee1 equal to new employee object. So the constructor first one is ID 20 and the first name and then last name and then his salary. This is floating point. In the same way, I'll create 2 more employees. .45F. Employee 3, the employee ID is 30. Pankaj Singh 4020.64F. So now after that we just need to save our employee objects within our collection. So we have the add method and we need to pass the employee objects that we want to save. So just like how we have saved integers, in the same way we can easily save any kind of objects as well, because here also we are saving only integer objects, which is nothing but a wrapper class around an integer. That's the reason you can directly send a normal primitive integers. In the same way, here also you are saving employees. So you have created 3 employee objects, because these are all non-primitive data types. You can't use as normal wrapper classes. You are supposed to create 3 employee objects and you have added them to hash employee objects, which is our hash set. Now, once after that, you can just go ahead and use your for each loop. And I want to print each and every employee. So this is a collection which holds list of employees or a set of employees. So that means each and every value that will be retrieved from this collection, it will be of type employee. Just like how you have retrieved an integer from the integer hash set collection, here also from hash set of employee you can retrieve all the employees, and you can see that I'm directly printing the employee object. So normally it will print employee object at hash code, but what I have done is I have overridden the toString method to provide some meaningful definition. Just like how we have followed in exception handling for our custom exception, we have overridden toString method to provide a meaningful definition of the custom exception. So the toString method was available in our object class, and you can easily override that method. And whenever you are using in system.out.println, this will automatically call the toString method, and implicitly it will resolve the call to toString method which you have overridden. So now you can see that with each object, it was able to provide some meaningful definition about the object. Employee Stephen Lee, the first name and last name, with ID 20, has salary 1000.24. Employee Pankaj Singh with ID 30 has salary 4020. Employee Chris Brick with ID 10 has salary 3050.45. Let us implement the same with respect to TreeSet. TreeSet objects example.
Krish, 1 second, can you go back to the program, Krish? Krish, you have inputted employee 2 first, right? Meaning put into the hash set employee 2.
Okay.
Before employee 3. Employee 2 is Krish, but in the output we are getting Pankaj.
Okay.
How is that possible, Krish?
Did you remember what is the purpose of HashSet and TreeSet?
Yeah, no duplicate.
Okay.
And the order is maintained in TreeSet, right?
Okay. So for HashSet, will it maintain the order?
Oh, okay. Okay, got it.
You got answer? Okay, cool. Oh yeah, correct, Isha. Let us copy the same code. No need to write one more time. I'll just change it to TreeSet. TreeSet. Let us take our TreeSet example with respect to integers. So when we have verified with respect to integers, the TreeSet collection, even though we have inserted the data or we have added the objects in different format, different order, we are able to see that the data was in a sorted order. The reason for that is it will be implemented from sorted set, and TreeSet, it maintains the order. And another advantage with the TreeSet is that it will be provided with a backed set, which means you can just call a subset method and you can retrieve a subset of the collection which is backed by your main collection. So in the same way, we can easily save TreeSet with objects as well. So here I'm saving 3 employee objects. Yeah, we'll discuss about that, Adil. Now, let us go and execute this program and see what happens.
Krish, I have a quick question. What is the order in your? Sorry, what are the keys? Because every hash set hashes a set of key values, as far as I understand it. I don't know the keys here. Because we're just adding objects to it, but I don't know if the key is defined.
Key will be automatically defined by the JVM.
Based on what?
Did you go through the hash code generation? Did you?
Yeah, but I didn't understand that part. I don't know, like, based on exactly what they produce it.
Okay. For HashSet, it is only used to stare. Sorry, I'm hearing a lot of disturbances. I'm going to mute you. For HashSet, it will just store the data, and the purpose of set is to avoid the duplicate. So whenever we are using hash set or hash map, it will make use of a hash table, and instead of directly storing the object, whatever that you have passed, it will make use of the hash code that will get generated by the object, and internally it will be developed by the JVM. So we don't have any access to how to generate the hash code or what kind of code that will be generated by the JVM to store the object. Ultimately, you can only receive the object whenever you are trying to pull the objects from the collection.
And is there a way to print the keys actually?
No, that's what I'm telling. We don't have any access to those stuff.
Okay.
Yeah.
No problem. Got it.
Yeah. Okay, with respect to TreeSet objects, I'm trying to save 3 objects within TreeSet, and you can see that I'm getting an exception specifying that class cast exception com.collection.employee cannot be cast to java.lang.comparable. Normally, the class cast exception will come whenever you're trying to change the data type from one class to another class. In a sense, let us say you got directly an object from a method call, but it's not possible to work on the object if you directly get a superclass object class. So you just want to convert to some other class, just like the box class or box weight class. If at all, if the returned object was not possible to convert to box or box weight class, it will give you the class cast exception. In the same way, here also, what is the error message here? Here it is saying that com.collection.employee cannot be cast to java.lang.comparable. The purpose of TreeSet is to store the objects in a tree format. In the sense, we want the objects to be stored in a ascending order. If at all, if you are following the natural sorting techniques like 0 to 0, 1, 2, and so on for numbers, and A to Z for alphabets. But currently, we are not storing any integers or string values or characters within our tree set. We are trying to store some objects. If you go back to your existing tree set example for integers, we know how to sort the integers because we already know that whenever we are trying to insert a new integer, JVM can easily identify the position where this will be fit in the collection. So even though if you are inserting 34, it knows that it was supposed to go after 30 only. So if you are trying to insert 10, it knows that it was supposed to be put at the starting position because all the remaining elements are greater than 10. But when you're trying to store the objects, even the employee object consists of several instance variables, that's fine, but you are still directly inserting the employee objects into the collection. So that means you are inserting employee 1, employee 2, and employee 3. So you should externally specify how to compare employee 1 and employee 2 and decides which one should come first and which one should be followed. Because if you're directly inserting an object, to a collection like TreeSet or tree map, it won't understand, JVM won't understand that how to compare between these two objects, and it was not possible for JVM to decide what is the position of the second object. Let us say I'm not inserting two objects. I'm only inserting the first object. In this case, you can see that I'm able to insert properly and I'm able to print the object also, the employee object also from the hash map. The reason for that is you are having only one object and it's not required to decide where it will go inside your collection. But when you're trying to insert more than one object, you should specify that what is the position of employee 2 with respect to employee 1. That will be specified by using an interface called java.lang.comparable. So whenever you are writing or whenever you are trying to store objects within your collection, that object, currently our employee object, must implement an interface called comparable interface. So currently we are trying to insert employee objects. Go back to employee class and implement an interface called comparable. The comparable also a generic interface, so you should specify on what basis you want to compare, what kind of objects. Currently I want to compare based on employee objects. So normally whenever you are trying to implement an interface, you are supposed to provide a definition for all the abstract methods. Currently I have only one method in my comparable interface, which is compare2. The compare2 is a method, is an abstract method which accepts an object in the sense, in our current case, generic, which is employee. So the method compare2 will be called on an object only. Object in the sense, the compare to method, normally it will be implemented in our employee class. So this is an instance method now in our employee class. So to call compare to method, we need an object as well. So let us say we are calling on employee 1, the compare to method called on employee 1. So you are asking to compare with another object which is employee 2. So that means internally we are passing employee 1 to compare to method, and we got one more parameter as one more employee object as parameter. So now you can decide based on what instance variable you want to compare the employee objects. So the purpose of compare to method is it will verify both the objects and it will decide like which one is greater or which one is smaller, or whether both are equal or not. So that means the return value should be an integer. So if it is less than, then we need to understand that employee 1 is less than employee 2. That means employee 1 should come first. And then employee 1 greater than employee 2. And in the same way, employee 1 equal to employee 2. So then they'll be followed one by one. So currently we have 4 instance variables: first name, last name, employee ID, and salary. So let us implement the comparative method which accepts T. So current case T is employee itself. So that means I got the current class object. Current class object is nothing but employee 1, and I'm taking the last name as my comparator value. So I just want to compare based on last name. So I'm taking from the current object, I'm retrieving the current object last name, and the string has a method called compare2, which accepts another string, and it will verify. Let us say if you have passed alphabets, normally if you pass alphabets or numeric kind of stuff, and string knows, the comparative method knows how to compare between these two strings based on alphanumeric. So whatever the object that I have received, I'm retrieving the last name from that, and I'm verifying with the current object last name as well, and this will return, the comparative method will return a positive, negative, or a 0 sign, specifying that whether both are equal or one is greater or which one is smaller. So based on this strategy, whatever the objects that you are trying to insert, so now you are inserting 3 objects. So whenever it will try to insert the second object, the employee 2, it will verify, it will call the compare2 method. It will call the compare2 method between those two. So current case is employee 1 was already there, and the next one is employee 2. So between these two, it will take the last name. So currently last name is the third one. So it will take the last name and it will compare the first one, Lee and Brick. Here you can see that Brick will come first. And next it will try to insert Brick and Sing. So Sing, it will come last. So then it will arrange the elements or the objects in an order called this one will come first, and this one followed by this one, and then followed by Pankaj Singh. So here you can see that I have inserted the data 20, 10, 30 as objects, and here you can see that 10, 20, and 30, because I am comparing the objects based on Brick, Lee, and Singh on last names. What if there are multiple bricks? You just need to verify that once you have received this example, Adil. Let us say I want to change the comparison based on first name. So Steve, Chris, and Pankaj are the first names, and Chris should be followed by Pankaj, and then it was supposed to followed by Steve. Chris, Pankaj, then Steve. So whenever you try to store objects, within your collection, you are supposed to go for implementing the comparable interface and provide your own definition for that. If you take a look at the API for our integers, you can see that it is already implementing the interface, which is comparable interface, which means integer class, whenever you're trying to store the integer class, Java will call the compare-to method within this level, and it will be decided based on the natural sorting order. Last time we had discussed about the other part, which is map related stuff. The map interface, which is used to store the data in terms of key value pairs. But all these classes on the left side, they are only used to save the normal objects. And whenever you want to retrieve the data, you'll just go and get the data by using the object name, or you'll use the iterator, or for each loop to iterate through the collection. But here on the right side, the map collection, it holds the data in terms of key value pair, which means you can just ask based on what key you want to retrieve the data. But here you are directly getting the values from the collection, but here you can mention what is the name of the key for which you want to retrieve the corresponding value. Even map interface, it was followed the same structure. There will be an abstract map available, which is extended by hash map and tree map, and again implementing the map interfaces. Here I didn't place that one, but it was there. Hash map and tree map, these two are just like HashSet and TreeSet. Hash map, it uses hash table to store the data, and the hash table generation, it will be for the keys. One thing to be remembered with respect to map is keys should be unique. So that means you shouldn't place a duplicate key. even if you try to use a duplicate key, the existing key value will get replaced by your current statement. I'll show you how it will be done. Tree map. The purpose of tree map is to sort the data based on keys. So that means the sorting will be done based on keys, and the corresponding values will get allocated as specified by the key order. Map does not implement iterable interface, which means you can't use the iterator method. So to iterate through the collection, you have some other way, which is entry set method. So the entry set method, it will provide you a set representation of the map. So it will just represent the map collection in terms of a set representation. So once you got the set representation, you can make use of iterable interface, which provides an iterator method, or else you can go for each method. So here we have seen the methods like add and remove, but here we don't have add and remove. We'll be having like put and get. The put method is used to put the data into the collection, and the get method, it accepts a key. The key can be, you can pass a normal primitive data type, or you can make use of any of the non-primitive data types like the objects which we have seen with respect to HashSet or TreeSet. And remove of key, this is used to remove the key value pair from the map. Whenever you say remove of key, it will verify whether the key was available in the list or not, and it will try to remove that key value pair from the map.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website H2KInfosys.com. On our website H2KInfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.